Hello. So in this video, I'll be going through quadratic simultaneous equations. So with these types of these pair of equations, you can't use elimination like you would with linear simultaneous equations. So instead, you should use substitution. So what substitution is you either find an equation in terms of x or y. So firstly, let me just label each one. So this is equation 1 and this is equation 2. So it's easier to work with equation 2 because it's only up to, there's no power of 2. So now we should make it into the equation in terms of x. So make x the subject, or you could even make y the subject. So I'll demonstrate it using both ways. So make x the subject. Make y the subject. So over here we have x equals to y plus 2, and you rearrange. So now we have x as the subject. So now that we have this, we can substitute x equals to y plus 2 into equation 1. Equation 1 here. So instead of the x in equation 1, we replace y plus 2. So that becomes y plus 2 squared plus y squared equals to 34. And now if you expand the brackets, y plus 2 squared, you get y squared plus 4y plus 4 plus y squared is equal to 34. So now 2y squared plus 4y plus 4 equals to 34. Now you could take out a factor of 2 from both sides. 2 times 17 is equal to 34. And now we divide both sides by 2. Divide both sides by 2 gives 1, so the 2's disappear and becomes y squared plus 2y plus 2 is equal to 17. Therefore, if you move the 17 over, subtract 17 from both sides, y squared plus 2y minus 15 is equal to 0. And now this is a quadratic equation which you can solve either using the quadratic equation or by factorizing. If you factorize, you get y plus 5 times y minus 3 is equal to 0. So now either y plus 5 is equal to 0 or y plus 3 is equal to 0. So either y plus 5 is equal to 0, which gives y as negative 5, or y minus 3 is equal to 0. One of them must be equal to 0 so that when they multiply, they're 0. This is why we're doing this. So we get two solutions here. Y equals to negative 5 and y equals to 3. So now what we do is we take these two solutions and we substitute them back into this original x equals to y plus 2. So when y is equal to negative 5, when y is equal to negative 5, x equals to, now substitute negative 5 into the equation, y equals negative 5, and replace y with negative 5. So x becomes negative 5 plus 2. So therefore x is equal to negative 3. That's our first solution. And our second solution is when y is equal to 3 from over here. Y is equal to 3. When y is equal to 3, x is equal to, now you take this, y equals to 3, and you replace the y here with a 3. So that becomes x equals to 3 plus 2. So therefore y is equal to 5. Sorry, x is equal to 5. X is equal to 5. So here we have our two solutions. These are our two solutions for the quadratic simultaneous equation. And in the exam, we should substitute them back into the original equation, into 1 and 2, to check that they work. So now let's make y the subject. And so from the equation number 2, y is equal to x minus 2. So now we replace y equals x minus 2. We substitute that into the first one. So x squared plus x minus 2 squared equals to 34. So x squared plus x squared minus 4x after expanding the brackets. So now 2x squared minus 4x plus 4 is equal to 34. Now we take out the factor of 2 from both sides, same as what we did last time, and divide both sides by 2. So the 2's become 1 and cancel out. So now we have x squared minus 2x plus 2 is equal to 17. And x squared minus 2x minus 15 is equal to 0. So this time we have x minus 5 times x plus 3 is equal to 0. So either x minus 5 is equal to 0. One of them must be equal to 0 so that when they multiply, they equal to 0. And if x minus 5 is equal to 0, then x is equal to 5. Or x plus 3 is equal to 0 and x is equal to negative 3. So now we take our solution, one solution, x equals negative 5, and substitute it into the original, into the equation with y as the subject, which is y equals x minus 2. So we replace x here with 5. So when x is 5, y is equal to 5 minus 2, therefore y is equal to 3. And this is our one solution. Y is equal to 3 and x is equal to 5. And the other one, we have x is equal to negative 3. So we take that and we substitute that value in back to the equation with y as the subject. So we get y is equal to negative 3 minus 2. So y is equal to negative 5. And that is our other solution here. And if you check with the other side where we made y x the subject first, we see that we have the exact same solutions. This corresponds to this one here, and this one corresponds to this one right here. So and they're equivalent. So yeah, that's all on quadratic simultaneous equations that you need to know. So now I have a question for you to solve. Solve this question and let me know in the comments what the right answer is.